Hello and welcome in this video where we are going to introduce the complex plane, and also we are going to do 3 exercises to get you really familiar with complex numbers. If you remember this slide from the introductory video, you remember that we have extended the current number system to include square root of negative number. For example, here I can write square root of -1. But for the reason that we mentioned in the previous video, we are going to write y instead. It's better to avoid some confusion, and also it's way easier to write and to say. Of course, in this new world, we will also find multiples of I. For example, for I can have, for example, -3i, things like that. And now, my problem is the following one. We have seen that all the real numbers can be placed on the real number line. So, for example, -2, I have placed it here. Square root of 2, pi, everything is well placed. But now I'm wondering, where can I place all these new numbers that I have in my new number system? Obviously and sadly, there is no place for them on the real number line. My question is, what can I do with them? So the trick that we are going to do is that we are going to create a line just for them. And this new line will be called the imaginary line, at least I will call it this way, and it will be reserved for these new imaginary numbers. We are going to place this line perpendicularly to the real number line, call it imaginary line, and also I have put some graduation just to place imaginary numbers more easily. This is what I'm going to do now. So this number I, for example, where will I place it? I will place it in the imaginary line. For example, here. In the same way, for I will be placed a little bit higher, and -3i here. And maybe at this point, we can clarify the quote from Gauss that we have seen in the introductory video. Gauss said that one of the main problems with this subject is that it suffers from a very bad terminology. And instead of calling them imaginary number, it would have been so much better to call them lateral number. And that's because instead of seeing them as just imaginary, strange number, it helps to imagine them as simply a new number line that we have created by opposition to this real number line that we know from a long time. We are not at all going to talk about that in this video, but there is even bigger sets. And the reasoning is quite the same. There is numbers in this even bigger sets that we cannot place neither here and neither here. And so, by construction, we are going to create again another line, and so on and so on. But of course, it's not at all the subject of this video. But now maybe you have a better intuition of why we are going to do it like this. Having said that, maybe now you are wondering, well, is there numbers here in between? The answer obviously is yes. Some numbers are complex numbers in the sense that they have an imaginary part, but also a real part. For example, there is the number 3 plus 2i that I can place on the number line. Let's say the real part here, this is how we are going to call it, is on the 3, and the imaginary part is on 2. So I will place my number like about here. Let's summarize what we have so far. Any complex number can be written in this form. There is other way to write complex numbers, but we are going to start with what we call the rectangular form. It's probably the most intuitive form if you remember the complex plane. For example, let's take this number that you have already placed on the complex plane. There is this real part here, and there is this imaginary part here. The imaginary part, it's to say how much of this imaginary unit I want in my soup. Okay, so if you want a cooking analogy, you have only 2 ingredients. You have some real ingredient and you have some imaginary ingredient. And here we took 3 units of some real ingredient and we mix it with 2 units of imaginary ingredient. This right here, as I said, will be called the wheel part, and this is how we are going to denote it. The wheel part of this number z is equal to 3. Okay, and in the same way, this is the imaginary part. So without the I, the imaginary part is how much of the imaginary unit we want, but without taking the actual imaginary unit. And here what we are going to write is that the imaginary part of this number z is equal to 2. And again, every complex number that you will encounter in your complex journey, I would say, can be rewritten in this form with some real part and some imaginary part. Okay, so in this slide, I recap all the terminology that we have used so far. Complex number often denoted with z, have a real part, an imaginary part. This right here, this way of writing complex number is called rectangular. And this is often how we denote the real part of the complex number z. And this is often how we denote the imaginary part of the number z. And in this case, it's respectively a and b. So I hope that so far you are not too impressed with all this new terminology and all this new theory. And I think it's now time to see a little exercise to show some examples and clarify everything. Just before doing that, I wanted to do a very quick remark. Maybe you are surprised that I introduced the complex plane so early in my explanations. Maybe your teacher waited till the end of the chapter to show you about the complex plane. Well, first of all, my goal is not to do exactly in the same way as the teacher, otherwise my videos are useless. But most importantly, in math, I really want you to think visually, but especially in this chapter. Every time that you encounter some complex numbers, I want that the complex planes pop in your mind or somewhere in the back of your mind. Really think about complex number as being like arrows, vectors, points in the complex plane, as you want, but as long as it is more graphical. So I really encourage you to make pause to this video and try this exercise very seriously. Here the goal is to place those complex numbers in the complex plane. And before doing that, each time we are going to check what is the real part and what is the imaginary part of each complex numbers. Having said that, let's try to place the number z1. First of all, what is the real part and the imaginary part of this number? Well, the real part is the one that is not sticked with I, and the imaginary part is the one which is sticked with I. So let's complete here. We are talking about the number z1. The real part here is 3. And the imaginary part here, be careful, it's 2, not 2i. Remember here, if we want to take the cooking analogy, the goal here is to say that if we want to cook that, we have to take 3 units of real ingredient and 2 units of imaginary ingredient. So the I will never show up here in the imaginary part. The imaginary part is how much of imaginary do I want, but well, without the I here. Okay, it's important. Now I'm going to place it on the complex plane. So the strategy here is to identify, well, how much of the real ingredient I have, how much of the imaginary ingredient I have. The real part of the number is 3, so I will be here at 3 on the real number line. And imaginary part is 2. I have 2 of my imaginary units, so on the imaginary line I will be here. And if I intersect these two things, my number is here. So either I place a little point like that, but what I will very often do is to represent it with some kind of position vector. First of all, why not? And also you will see that in some sense, when we are going to add complex numbers, it will behave just like vector addition. So why not represent it like that? It's very practical. So if you agree, let's try the second complex number, and again, try first by yourself. So here it might be a little bit more difficult to identify the real part and the imaginary part. And the reason is that, well, we often have the number written like that, so here it's easy, but here it doesn't quite resemble that. So maybe the first thing that you can do is to write it in this form. And the question is how much, again, in the cooking analogy, how much real ingredient I have here? The answer is 0. I have no real ingredient. Okay? And how much of imaginary unit I have? So how much of imaginary ingredient? Well, I only have one single little I. The answer is 1 imaginary ingredient. Now that we have done that, maybe it's more easy to identify that the real part is 0 and the imaginary part is 1. So the A here, it's this 0, the real part, and the imaginary part B here, it's 1. Let's try to place it now on my plane. In terms of real ingredient, I have 0, I'm here, and I have 1 unit of imaginary ingredient, I'm here. And actually I will stop here, that's my endpoint. Again, I'm going to represent it with a vector, a little vector here, I hope you see it on the video, but it's just this little vector here of 1 unit on the top. Let's just add the name of the number and we are done. So now I think now you see the pattern. Here the real part is simply what is not stick to I, it's just 4. And in terms of imaginary part, it is -2. So be careful with the sign, don't forget to include it. Here the imaginary part is -2 and not 2. Having said that, I'm going to place it on the complex plane. I have 4 units of real ingredient, -2 units of imaginary ingredient, so I go here on the bottom. You see I have 4 of real, -2 of imaginary, and where it will cross, it will land here. And just name the number and we are done for this one. Here we have quite the same problem as before. It's not really easy to identify A and B since it don't really look like this. The first thing we are going to do, of course, you don't have to do that just in the beginning, but you will quickly get used to that and you will see immediately the real part and imaginary part. But here one last time, let's try to rewrite this in this way. So how much of the real ingredient we have here? Actually, we only have real ingredient, so it's -3. And I have kind of said it already, but how much of imaginary ingredient do we have then? Or 0. We don't have any imaginary ingredient, it's just a real soup. Okay, maybe I must stop with the cooking analogy, but here it's like it's only real number, no imaginary part, so I will write 0 I. So for the real part here, -3, the imaginary part is 0. Again, on the complex plane, we have -3 of the real ingredient, so we land here, and 0 imaginary. So actually we won't use this new lateral imaginary line, this new lateral axis. We are going to stick on the real line since it's just a real number, it's -3. I will just name the number and again we are done. Try the last one by yourself because there is a little trap. Check out what is the real part of this number and be careful here. What was the real part again? It's the part that is not stick to I, and it's how much of the real ingredient do I have. The answer here, it's -2. Okay? Often you will see that it will be written like this. So the real part will be written first, the imaginary part after, but at the end there is no reason that we cannot invert this. So sometimes you will see it in the other way around, but still the real part is the one which is not stick to I. Also, don't forget to include the signs. So here the real part is -2, and the imaginary part, well, it's a little bit hidden here, but we have a 1 that is not written, but it's present anyway. So -1. To place it on the complex plane again, -2 in terms of real ingredient, -1 in terms of imaginary, and we land here. We name the number and we are done. And that's already the second exercise of this video. and it's exactly the opposite as the previous one. Here you have already the complex number placed on the complex plane, and I want you to write it on the rectangular form, the form that we have used so far. Z1 is this one. Please try first by yourself. So how much of the real ingredient we have? We have 2. And how much of imaginary ingredient, imaginary unit? -1, -2, -3, -4, -5. So here we are going to write 2 for the real part and -5, so not plus, sorry, -5 for the imaginary part. For this second complex number, where are we? And so we have to take -2 on the real line, -2 on the imaginary axis, and we land here. So real part -2, imaginary part -2 again, the little I, and it's done. Finally, my third complex number is here, on the real line, which is a strong indication that my complex number will just be a real number. And what complex number? -1, -2, -3, -4, -5. No imaginary part, so the imaginary part is 0 if you want. We are not obliged to write it. We can write 0y, but it's not how you have written real numbers so far in your life. So let's just stick with -5. And that's already it for this exercise. And that's the last exercise of this video. And it's just to show you that even though most of the time complex numbers are going to be written with the I, sometimes you may see this notation. Of course, it's quite easy to navigate between these two different forms of writing. You'll just have to remember first the definition of I. I is the number that when squared is equal to -1. Another way of saying that is that I is the square root of -1. So far it's just the definition of I, so nothing crazy. And we are going to use it to rewrite these complex numbers. For the first one, I will let you guess, but here, square root of -1, well, we are just going to replace it with y. So it's equal to 1 plus 2. To place it on the complex plane, let's identify the real part and the imaginary part. Really try to do it by yourself. Again, there is a little trap here. The real part is written at the end, so the real part is 2. And the imaginary part, it's a little bit hidden here, it's 1. So 2, 1, and we are here. Maybe a little bit more challenging is this second complex numbers. So how exactly are we going to extract the I, which is somehow hidden inside the square root? Here is how we are going to operate. We are going to rewrite this as square root of, write a big square root of -1 times 9. And I'm going to break the square roots. Up. By the way, I'm just using this formula that you have learned previously. You can just break the square roots when you have a multiplication inside. And then, of course, the goal of doing that is, again, to transform the square root of -1 by I. Also, -9 is 3. So the value here is 3i. Let's place it on the complex plane. There is no real part here. It's a pure imaginary number. So it's a complex number, but only with the imaginary part. And we are going to stop here at 3. For the last one, the challenge is just not to get lost with all these negative signs. Please do not cancel these two minus signs. It's not how it works. There is no reason to do that. You might want to do that because when you have parentheses here, you know that you can just eventually cancel the signs. But here it's not the equivalent of parentheses, okay? Let's say, for example, that you have -5 exponent, I don't know, 10. Well, here you cannot exactly cancel the negative signs, since here it's a whole expression by itself, so you cannot do that. So I'm just going to recopy the first negative signs, and then the square root of -25, I will copy is at -1 times 25. Again, I will split the square roots. I have -1, negative 25. Here, negative 25, I will directly write 5. Sorry, square root of 25, I have replaced by 5. Square root of negative 1, I will replace by I. And the final answer is minus 5i. Here again, you have just a pure imaginary number, so we are on this imaginary number line. In the other direction this time, minus 1, minus 2, minus 3, minus 5. Here we are. And that's it for this exercise. So the purpose was just to show you that sometimes you may still encounter this kind of writing, but it's not the end of the world. Before stopping this video and leave you with the bonus, I just wanted to clarify very quickly the difference between an imaginary number and a complex number, because sometimes I say imaginary, sometimes I say complex, and we might think that it's the same words, but there is a little subtlety here. All the numbers that you have seen in your life are complex numbers. Okay, so including all the real numbers that you have seen so far, but also the new numbers that we have just learned. All single one of them are complex numbers. This is why these videos and this chapter is called complex numbers. So let's fill here, for example, with some examples that we have encountered. Y minus 2, minus y minus 1, and so on and so on. But sometimes it happens that these complex numbers, that we can write like this, of course, in the rectangular form, it happens that sometimes there is no imaginary part. Okay, so the b is equal to 0. There is no imaginary part, and so there is only a real part. And in this case, this complex number, well, it's just a real number. Of course, it's still a complex number, but we can go further and say it's a real number. For example, 5 plus 0i, it's a real number. There is no imaginary ingredient, no imaginary part here. Of course, most of the time, we won't write 0i, and we are just going to let the number exist by itself. So I can also write, 8, for example. Okay, so again, all these real numbers that you have seen so far are just particular case of this set of complex numbers where there is no imaginary part. In this case, when there is no imaginary part, on the complex line, it means that we are on this line. Okay? When we are on this line, it means that there is no imaginary part, and so that it's a real number. It's also a complex number, but we can go further saying it's a real number also. When there is a mix between a real number and an imaginary number, where we are anywhere here in the complex plane, and it's just a complex number. This one, it's a complex number, it's a complex number. This one, it's a complex number, but also we can say it's just a real number. And now the last case, sometimes it happens that we are on this line. And where we are on this line, we will say that there is no real part, and the number is purely imaginary. This is why sometimes I say imaginary number. Well, it's also a complex number, but there is no real part. For example, 2i, I plus 0, and so on. Again, most of the time we are not going to write the plus 0 and just let I. Of course, all the imaginary numbers that are here are also complex numbers. But for this type of numbers, we can go further and saying that they are purely imaginary. To summarize, every numbers here are complex number. Every single number on this plane are complex number. But if they are on this line, we can also say, so they are still complex numbers, but we can also say that they are real. And if they are on this line, they are still complex number, but we can also go further and say they are purely imaginary. That's it for the video, and now I will leave you with a little bonus. So the exercise here is to complete with greater than, less than, or equal, and you have two complex numbers. First of all, we are going to place them on the complex plane. I think now you know how to do that. So -2 for the real part, 3 for the imaginary part. We are here for the first complex number. For the second, 4 for the real part, -1 for the imaginary part. We are here. And the exercise is to say which one is greater than the other one. Or maybe they are equal. What do you think? Pause the video and think a moment about that. And the answer is, there is no answer. Remember in the introductory video when we discussed about why it caused so much controversy among mathematicians, this new notion of square root of negative number, why it was hard to accept for mathematicians? We gave some example already, but one more reason is that when we allow square root of negative numbers to exist, we kind of lose this notion of ordering that you have always used with numbers. So far, you could always tell that one number is greater than another. Here, in the world of complex numbers, you can no more do that. So I don't know if it's a good news or a bad news. Maybe it's less work, so it's a good news. But it's finished for ordering numbers with the complex numbers. Thanks for watching and see you in the next video.